Running containers in production used to mean owning the servers underneath them too. Patching, sizing, and scaling, all of it. Fargate hands that ownership to AWS instead, launching containers directly while the services paired around it decide how the workload actually behaves. Wire that pairing well, and workloads scale and fail over cleanly without anyone babysitting a fleet of hosts. Wire it poorly, and unpatched hosts or a mismatched service choice eat your whole week. A microstack is a reusable and useful combination of two or more cloud services. Let's learn about AWS Fargate microstacks as featured on systemsarchitect.io. Subscribe to the channel and like this video. By knowing these, we can excel at choosing great solutions. We're going to cover 12 microstacks. Each one is useful and pairs Fargate with the services around it. 1. Route ALB traffic to Fargate containers backed by Aurora for highly available web applications. An ALB spreads traffic across a fleet of Fargate containers. No single container becomes a bottleneck. Fargate scales that container count up and down. There's no EC2 instance to patch or size. Aurora sits behind it as the data store. It handles automated failover on its own. What's the payoff? A small team runs a self-healing stack that once needed a whole infrastructure group. Pair ALB deregistration delays with Aurora Red replicas. That way, scaling never interrupts a live request. 2. Schedule CloudWatch Events to trigger Fargate tasks processing S3 data for serverless batch jobs. CloudWatch Events launches a Fargate task on a schedule. Fargate runs it as a short-lived container, and it exits when the job's done. S3 holds the input files and the output. It's the handoff point between runs. No cron server, no fragile instance, just compute that costs money only while it works. It suits nightly reports and routine maintenance well. Set a timeout longer than the typical run. That way, a stuck job won't quietly rack up charges. 3. Route API gateway requests to Fargate and DynamoDB for millisecond-latency serverless APIs. A PI gateway handles routing and throttling. It validates requests before they reach your code. Fargate runs the business logic behind it. There are no servers to provision or patch. DynamoDB is the data layer. It holds single-digit millisecond performance under any load. All three scale independently. Cost tracks usage instead of a fixed over-provisioned size. Use DynamoDB's on-demand mode with Fargate's auto-scaling. Neither layer then needs manual planning. 4. Deploy ECR images to Fargate with CloudWatch monitoring for reliable container observability. ECR stores your container images, versioned and scanned. They're ready the moment a task needs to launch. Fargate pulls straight from ECR to run them. There's no Docker daemon to host yourself. Why does this matter for microservices? CloudWatch layers on top of both. It collects logs and metrics in one place. A single gap in that visibility is exactly where a small problem turns into an outage. Alarm on both container memory and ECR scan findings. Performance and security issues then surface through the same path. 5. Isolate Fargate and RDS inside a VPC for secure enterprise database workloads. A VPC gives you full control over network boundaries. You define the public and private subnets yourself. Fargate containers run in private subnets. They have no direct route to the internet. RDS lives in its own private subnet. It's reachable only from the application tier. No public IP, no direct route, no exception. This is the pattern regulated workloads usually require. Use separate security groups per tier. A compromised container still can't reach the database directly. 6. Shield ALB and Fargate with a web application firewall and Route 53 for secure public-facing web apps. The ALB routes traffic to Fargate like a standard setup, but here it gets 2 extra layers of protection. A web application firewall sits in front. It blocks SQL injection and cross-site scripting before they land. Route 53 handles DNS and health checks. It fails traffic over if a whole region goes down. That's a public-facing stack that's defended and resilient. Start firewall rules in count mode first, then switch to block once you trust them. 7. QSQS messages to Fargate and S3 for reliable asynchronous processing. SQS holds messages that need async processing. A burst of work never overwhelms what's downstream. Fargate tasks pull that queue. They scale out when it backs up and back in once it's empty. Results land in S3 as durable storage. Other systems can pull from it independently. If a task fails mid-job, SQS simply returns the message. Another task then retries it. Pair a dead letter queue with the primary one, so messages that keep failing don't loop forever. This is a condensed version of what we have on systemsarchitect.io. See the full section there. Also, make sure to like the video and subscribe to the channel for more, and check the video notes for links. 8. Authenticate API gateway requests with Cognito before Fargate and Aurora for secure SaaS APIs. Cognito manages sign-up, sign-in, and the token's API gateway checks. Every request gets verified this way. Once authenticated, it's routed to Fargate containers. Those containers read and write data in Aurora. Why skip building your own login system? Cognito already handles multi-factor auth. It handles social login too, with no extra code from you. Scope Cognito user groups to API gateway resource policies. Authorization then lives at the edge, not inside every container. 9. Automate code pipeline deployments to ECR and Fargate for continuous container delivery. Code pipeline triggers a build on every code change. It pushes the new image into ECR. Fargate picks it up, rolls it out, replaces the old containers. CloudWatch watches the whole rollout. It surfaces errors before they turn into an incident. Because ECR versions every image, rolling back is just redeploying a prior tag. Wire the deploy stage to CloudWatch alarms. A bad release then halts itself automatically. 10. Distribute CloudFront traffic through a web application firewall in ALB to Fargate and Aurora for global low-latency apps. CloudFront sits at the edge, caching content near users worldwide. No one routes back to one distant origin anymore. The firewall inspects that edge traffic first. The ALB then distributes what's accepted across Fargate containers. Aurora backs those containers with real durability. This stack suits users spread across continents. It still needs real security guarantees, too. Configure cache behaviors per path. Dynamic API routes skip the cache. Static assets benefit fully. 11. Trigger event bridge events through SQS to Fargate with ElastiCache for high-performance event processing. Event Bridge routes events into a bus. It forwards matches into an SQS queue. Fargate containers consume that queue. They scale with event volume in either direction. Why add a cache into the mix? ElastiCache holds session data and lookups in memory. That beats hitting a slower database every time. Size it for your peak load, not the average. Evictions under pressure quietly bring back the latency this pattern removes. 12. Layer ElastiCache sessions onto API Gateway, Cognito, Fargate, and Aurora for full-stack secure apps. This last microstack adds a caching layer for session state. API Gateway fronts traffic, and Cognito authenticates in it. Fargate runs the logic against Aurora as the system of record. ElastiCache holds session data in memory. Repeat lookups for the same user skip Aurora entirely. 5 services work in concert with nothing left to patch by hand. Match cache expiration to your Cognito token lifetimes. Cached sessions then fall out of sync with expired credentials instead of lingering. To wrap up, AWS Fargate turns container ops into a configuration problem. Each microstack pairs Fargate with services for traffic, storage, security, and monitoring. Your team owns the application, not the infrastructure underneath it. Start with whatever combination matches your workload today. Layer in the others as your system grows. Well, that's it for now. Hope you got something out of it. Find a lot more articles and guides on both systemsarchitect.io and codeguides.io.